I welcome you all to the course on process instrumentation, dynamics and control. This course is offered to undergraduate students of chemical engineering, and today's session we are going to see on the introduction to the course and what are the syllabus that we have in this course and the books that we are going to refer and mainly the course outcomes. So let us go into the course. So introduction to the course. From the topic process instrumentation, dynamics and control, we can see that each word has a different understanding. One is process, other one is instrumentation, and another one is dynamics, and another one is control. Here in process instrumentation, I refer the instrumentation which is related to process. The process here in chemical engineering course, it refers to the chemical process. It can also be electrical process or it can also be mechanical or thermal process. As far as chemical engineering is concerned, we are going to deal only with the chemical processes. So the instrumentation part that we are going to see here is the different types of instruments used for measurement of the process variables. Here the process variables I refer to temperature, pressure, flow, level and etc. So there are many instruments which are used to measure these process variables. For example, you can have transmitters, sensors, controllers, etc. for measuring all this used as a measuring element for this process variables. So here the first and the second word refers to the process and instrumentation. Process refers to the chemical process and instrumentation is dealing with the study of different instruments which are used for measurement of the process variables. Okay, so coming to the third word which refers to dynamics. Dynamics in general is like it is changing with respect to time. Here in process control, it refers to the dynamic characteristics of the process, transfer functions and mathematical modeling of the processes. For example, all processes are not under steady state conditions. Steady state I refer to the condition which is not changing with respect to time. So all processes are dynamic in nature. Either the process parameters or the conditions, all the parameters are changing with respect to time. So all being the function of time, we wanted to study the characteristics of the processes under dynamic conditions. So we are going to check with the time constants and delays and transfer functions of different mathematical models of a process. Here also I refer the process to chemical processes. And the final one is control. Control is the feedback control principles and the PID controllers. Here we are focused only on the feedback control and the PID controls. Feedback is nothing but when the information that is fed back to the controller will act accordingly to the error that is being received. Based on the error as an input to the controller will produce as an output which is executed by the final control element. Here in controller part, we are going to discuss on the different types of controllers that we are going to use, especially the PID controllers. PID controller refers to proportional, integral and derivative controller. So finally, this control will also include the tuning of controllers for optimal performance and stability analysis and the control system performance criteria. For example, we are going to discuss on the Bode and Nyquist stability criteria in this course. So overall, this process instrumentation dynamics and control, which refers to the process and the instruments that we are going to study for measuring the process variables and the transfer functions of the and the modeling of the processes and the control mechanism. So next, moving on to the syllabus, we have 5 modules. The first module will cover on the instrumentation parts. It includes the principles of measurements and classification of the process instruments and measurement of temperature, pressure, fluid, viscosity, concentration, and humidity. So in this module, we will see what are the instruments which are available for measurement of all these parameters. For example, if you take temperature, we have thermometer, thermocouple, optical pyrometer, radiation pyrometer, and if you measure the fluid flow, we have orifice meter, venturi meter. Similarly, there are many instruments which are used for measuring the parameters. We want to understand the characteristics of the instruments and dynamics of that instruments. So the first unit will cover all these things. The second unit, the open loop systems, we will give a small introduction to the Laplace transform and its applications. Students of chemical engineering, students are in their early semesters, they would have come across this Laplace transform. Again, this is included in process control, so it will be a refreshing one for the students. This Laplace transform is used to solve the differential equations. So we are going to study the different properties of the transfer functions and the first order systems and their transient response. Similarly, the standard input functions, first order systems in series, linearization, second order systems, the dynamics and transportation lag, which will be covered in the second module. And third module is closed loop systems. In closed loop systems, we will have a complete block diagram of the feedback control systems, and we are going to discuss about the two different problems that we come across in control system, especially the servo and regulatory problems. And as I said, we are going to study about the controllers and the final control element. Controllers, as I told earlier, we refer to the PID controllers, and the final control element is nothing but your actuators. So finally, in the third module, we are going to study about the transient response of control systems and their stability. Coming to the fourth unit, it is about the frequency response. Here we will have a small introduction to what is a frequency response and control system designed by frequency response techniques such as Bode stability criterion and tuning of controllers. Especially we are going to discuss on Ziegler-Nicholas tuning rules and coherent-cone tuning rules. Finally, at the end of the syllabus, we have a few advanced control systems. Advanced control systems I refer here as cascade, feed forward, ratio control, and chemical control of some processes related to distillation column and heat exchangers. So what will be the course outcomes? So once the students have undergone this course on process instrumentation, dynamics and control, the student will be able to apply the concept of Laplace transform to solve the differential equations, apply the first principles method to develop the transfer functions of the process, and they can develop block diagram, analyze transient response of control systems, analyze the stability of control systems and perform tuning of controllers, and explain different advanced control system strategies. These are the course outcomes the students at the end of the course will be able to apply. And coming to the end of the slide, the textbooks and the references book for this course, the students may refer. The first one is Kaufner. It is process systems analysis and control, and Stephanopoulos, chemical process control. And the references book that we are going to use are Seaborg, Merlin process control, and Smith. So these are the textbooks and references book the students can refer. So we have come to the end of this today's session. So first thing is, we have given an introduction to the course, and we have given what are the textbooks that we are going to refer, and what are the course outcomes, and hope this session will be useful to you. We'll have another session. Thank you.